Welcome, video example 8, unit 2, chemistry 1B. Okay, so we're going to calculate a standard delta G value from an equilibrium constant K. And we'll do it for a solubility reaction. So we have a KSP value for silver chloride at 25 degrees as given here. And we need to determine the delta G for this process. So this is the reaction. Essentially what we have to do is the reverse of the KSP equation. So the K value is 1 over the KSP value. So generally the KSP is written for this reaction here. So we have silver chloride as a solid going to silver ions and chloride ions. Okay, these are all aqueous, like that. Okay, so in order to reverse this reaction, the rules state that for an equilibrium constant, the reverse, we have to take the reciprocal of the KSP value, which means we end up with this value over here. Okay, then we can use the equation that relates delta G standard to the equilibrium constant as this one. So delta G is equal to minus RT ln K. Okay, and then we plug in the values. So we use the gas constant over here. We plug the temperature in Kelvin, and then the K value goes in here. But remember that we have to convert these things to kilojoules. So we have to multiply by the conversion factor for kilojoules to joules, because the answer you'll get will be in joules if you just don't use the conversion factor. And the answer comes out at minus 56 kilojoules per mole. And this tells us that it's a negative delta G, indicating that precipitation is going to occur. So if we take a look at this reaction here, if we add silver ions and chloride ions, we will definitely get a precipitate because the delta G is negative, indicating a spontaneous forward reaction.